All right, the number of people waiting in an auditorium for a rock concert to begin is modeled by the function n given by n of t equals 460t cubed minus 169t to the fourth plus 135 for t between 0 and 2. The door closes and the concert begins at t equals 2. How many people are waiting in the auditorium 2 hours before the start of the rock concert? Explain your reasoning. And part B, each person waiting in the auditorium heats up the room by 0.014 degrees Fahrenheit. Write a function h in terms of t that gives the temperature in the auditorium for t between 0 and 2 hours. Assume that the temperature in the auditorium is 72 degrees when no one is inside. All right, so beginning, we want to just isolate our variables and make sure we know what is what and what we're measuring. So I want you to pause real quick and just annotate, go through, pick your variables and make sure you understand what they mean. Hopefully, you identified your independent variable as time. That is your independent variable. And you identified the dependent variable as n, which is the number of people. I'll write this to the side. So t is the independent variable, and n of t is our dependent, right? This is the number of people. All right. So now that we have that, we also want to just consider the fact that t can't be less than 0 or greater than 2. That's important to note. And also that the concert begins when time is 2. All right, so the first question asks us, how many people are waiting in the auditorium 2 hours before the start of the rock concert? It's best to try and phrase this in terms of what mathematically are we trying to find. So go ahead and pause real quick and do that. Hopefully you realized that what you're trying to discover is 2 hours before the rock concert would be when time is equal to 0. And so you're trying to find how many people are in the auditorium when time is 0. So our plan for part A is simply going to be to find n of 0, in other words, when time is 0, and that's just going to give me 135 people. Good. Part A in our back pocket, so we're going to move on to the real meat of the situation, part B. So part B wants us to write a function, h, in terms of t. So right off the bat, I can go ahead and start putting this together. H in terms of t, meaning that my independent variable here is going to be t, and my dependent variable, right, is h. And h is going to measure the temperature, right? It gives the temperature in the auditorium. All right, and it's very important that we note that h is going to be the temperature. So we're going to write an equation that will give us the temperature. Other things that we know are that the room is heated up 0.014 degrees for every person, and then it started off at 72 degrees Fahrenheit. So the first step in writing any equation is just to think about what makes up the value or the whatever it is that we're trying to measure. What causes it to change? And so to help us understand this, I want you to imagine that you're in a room with 10 people. How would you compute the temperature if you knew that every person increased the temperature by 2 degrees Fahrenheit? I'll give you a second to think about that. Hopefully, in thinking of this, you realize, okay, every person increases the temperature by 2 degrees, which would give me an increase of 20 degrees. But it doesn't make a lot of sense for the room to be 20 degrees, and that's because there's got to be a temperature that it started off at. So if you think it started at 70, and then you were 10 people in, and each raised the temperature by 2 degrees, you're going to end up with a 90-degree room. So using this analogy, we can start to build our function here. We realized that how we found our function was we took the number of people, how we found our temperature, sorry. We took the number of people and we multiplied it by however much they increased the temperature. Let's just use 0.014 here. And then we had to add the initial temperature of 72. And once we have this step, this is the key step, now you're going to be able to build on that. So you can see here that the independent variable that we have is people, number of people. And that's a little bit of a problem because the question, the prompt asks us to write h in terms of t, right? We need our independent variable to be t. So I want you to pause real quick and think about what we now need to do to move forward. Hopefully you realize that we need to find how many people there are in terms of the time. So we need some sort of way of finding the number of people if we have the time. Luckily, we do. I want you to go find where that is. What you'll notice is that if I rewrite my equation, h of t, the number of people is simply n of t. All right? And we multiply the number of people by 0.014, and then we add 72. And this is the big realization, is that my function that I had before is actually what's going to allow me to compute the number of people. So the number of people is n of t. And I can take it one step further, because when I'm computing n of t, let's say that I wanted, for example, over here, I wanted to compute n of 1. How would I do that? Well, I would go ahead and plug 1 in for my independent variable in my function back up here, n of t. I would plug it in, I get 460 times 1 minus 169 times 1 plus 135. And that would give me my value. So now, all I have to do is incorporate that into my temperature equation. Remember, because I want to always compute the number of people, multiply it by the temperature each person adds, and then finally add my initial temperature. So I want you to go ahead and pause the video and try and write down our final equation for temperature, and then restart it and we'll check. Hopefully you wrote your new function, h of t, as 460 t cubed minus 169 t to the fourth plus 135 all times 0.014 plus 72. Remembering, of course, that the number of people is simply given by our expression from our first equation, n of t. All right, hope this was helpful. Check the second video for another